Okay, if we're going to solve this linear equation, we're trying to isolate the variable. We're solving for x. So to isolate that variable, this is really a review. So based on what you guys did back in the day, maybe in Algebra 1, you may have used columns to line everything up. I don't know. But the point is, I've got a 5 stuck to this by addition. I don't want it there. I'm going to subtract it over. So I'm going to have 3x left on the left side of the equation equal to 14 minus 5, which is 9. And then I'm going to understand that the number in front of this x is multiplied, so to move it, I have to divide. So divide by 3 to both sides, x equals 3. And also back in the day when you first did these, maybe you took these answers, you plugged them back into the original equation to check. Always a good idea. But just understand, I'd take the 3, I'd replace the x up here, multiply to 3, get 9, add 5, get 14, it would check out. Right, we could do that. That's the nice thing about equations. All right, let's try another one. On number 2 here, we've got 5 equals 22 minus 4x. Kind of like we saw with simplifying expressions. Common mistake we made sign mistakes, right? So we start putting things on other sides, we start throwing negatives in front, it's possible sign mistakes could creep in. But if we're being careful here and we're being consistent with what we did on the first problem, there's your x term, right? You want to take this 22, you want to subtract it over there, right? So if I subtract 22 over here to 5 minus 22, it's negative 17, right? That equals negative 4x. Now, I didn't write this as a step on the last one, but we're understanding whatever's in front of x, you're dividing. And if I write it as a step on this one, it's a little nicer because you get to see how the fraction is formed, right? Fraction answers are a possibility. We divide to isolate the x. You've got negative 17 divided by negative 4. Negatives would cancel out. You're left with simply 17/4. If you end up with a fraction scenario, leave it as a fraction answer, okay? Just make sure it's reduced. 17/4 is reduced. You want to divide that over to a mixed number, make it 4 1/4 just to show off your skills. More power to you. But that's an extra step you don't have to take as far as I'm concerned. Okay, stepping it up a notch. This time we're going to take 5 minus a quantity. So parentheses involved, 2 minus 3p. That's going to equal 10. Whenever we see parentheses within an equation, just like when we see parentheses when we're simplifying an expression, we want to get rid of that set of parentheses, right? We want to do some kind of distributing. So here, you've got the negative out front. You're going to distribute that negative through. Changes the signs on the terms in the expression inside the parentheses. From there, parentheses no longer necessary, combine like terms. I've got 5, I've got minus 2, I've got 3, plus 3p. All of that equals 10. You have to simplify each side of the equation before you can start shuffling things around. So at this point, solving for the variable, I'm taking this 3, I'm subtracting over, right? So I could show that step, I could cross this out, but I'm subtracting it over. If I subtract it over, I've got 3p equals 7. Divide through by 3 if you want to show that step again like we talked about on the previous problem, because the fraction's being formed, more power to you. Either way, though, p is going to equal 7/3. Again, a lot of this should be serving as a review for this class, right? This should look awfully familiar. So we've seen 3 equations now where you got a variable on one side. We've talked about it, the importance of making sure each side is simplified before you start shuffling things around. What about an equation Another linear equation here where we've got variables on each side. Something like 3x minus 5 equals negative 3x plus 6. Well, you start off with the same intent, making sure each side is simplified, which each side is here because all like terms have been put together. There's no parentheses, so there's no distributing either, right? Here you just got to decide, okay, what do I want to move first? Doesn't matter. Normally I'll move the variables together. Like maybe I'll take this minus 3x. Maybe I'll add that over. I mentioned using columns. Maybe once upon a time when you did these problems, that's what the column approach looks like, in case you were wondering. I'm keeping all the like terms lined up. So here I'd have 6x. And I'd be bringing down that minus 5 because I haven't played with it yet. That would equal, this guy would be gone. I bring down that positive 6 because I haven't played with that yet. And this is what we always do in algebra, is we're always trying to take a situation and turn it into something we're already familiar with. So obviously at this point we're familiar with this. If this was the original problem, you'd add the 5 over. You'd have 6x equals 11. You'd divide everything by 6. So if necessary, write that as a step so that you can see your answer would be 11 over 6. Not a perfect world, is it? We're going to get these fraction answers probably quite a bit. Okay. Sticking with the theme of variables on each side. Recalling that we got to simplify before we can start shuffling things around. Let's take 4x minus 2. Multiply that to the quantity of 3x plus 6. Let that equal 2x minus 1. Got your two sides of the equation where on the right side everything is simplified, the left side it is not. You've got parentheses, so we got to distribute. If you distribute 4x, keep that kind of by itself for the time being, but we take this negative 2, distribute that through, got minus 6x, negative 2 times positive 6, negative 12. That all equals the 2x minus 1. We can simplify the left side of the equation a little bit further because we can combine like terms. So you got 4 minus 6, you've got negative 2x minus 12 equals 2x minus 1. Now we're ready to move the variables, right? You want to use that little column approach because we got a little more going on here, kind of like the last problem. I might take this 2x from the right side. I might move that over here. Even though it doesn't matter, you could take this 2x on this side, you could add that over here. But if I move the 2x by subtracting it over, I'd have minus 4x, bring down the minus 12, equals, these cancel, watching your signs, that's a negative 1 I bring down. Once again, we create a situation we're pretty familiar with, so I'm going to add that 12 over. You've got negative 4x equals negative 1 plus 12, which is 11. Divide by negative 4. X is positive divided by negative, so it's negative 11 fourths. Okay. I think the only other linear type I want to cover, since we're coming up with all these fraction answers anyway, is let's cover a scenario where a fraction is in play. You're going to have some problems that are a little, it might be a little intimidating with how many fractions are present, but let's talk about a strategy here that we can use that would help us to eliminate that whole fraction idea. Let's take 2/5 x, let's set that equal to 10. Pretty simple scenario here. If I have a fraction present and I would like to cancel out that fraction idea, what I would do is I would take this denominator Take that 5. I would multiply both sides by 5. Right? If you multiply both sides by that denominator, it cancels that denominator out. So 5's cancel. We got 2x left equals 10 times 5, 50. Pretty easy to solve from here. Divide 2 to both sides. X is 25. So there's a little strategy you can use even on some of the slightly more complicated problems where fractions are involved. All right, let's solve an absolute value one here where we have the absolute value of x equals 5. Just reviewed definition for absolute value. We know absolute value can branch off into two scenarios. So what we do here in setting up this equation is we say that x, the part we're taking the absolute value of, could equal the value over here it's associated with. That's one case. Or this idea that's inside the absolute value could also equal the opposite. So basic rule we're following here, if you see absolute value, you're setting up two equations. The first equation you're setting up, you just drop the absolute value, got your equation solved. The second one you're setting up, basically the same as the first, drop the absolute value, but set it equal to the opposite of this number. That gets you your two equations to solve. In this case, these are solved, right? So we've got our answers. If we wanted to go back and review a little set notation right now, we could have done this on the other problems as well. We could say that we've got a set here that involves two answers. If we went in numerical order, we'd say -5 and 5, right? If you leave it like this, though, where I say x equals 5 or x equals -5, that's fine, too. That's good. Now, I'm going to throw this next one up here right next to this problem so we can make a connection. I'm going to take the absolute value this time of x equals -2. If I'm consistent, and this made any kind of sense over here, well, I just drop the absolute value, set that equal to -2, right? And then I do or, drop the absolute value, set x equal to +2, right? Why is there no solution to this problem? Yeah. There you go. You got to remember what absolute value means in the first place. If you're going to take the absolute value of something and you don't know what that something is, well, we at least know for sure the absolute value is going to be positive, right? So if I got absolute value and it equals a negative number, there is no solution. Got to watch out for those. Try to keep you honest like that. Okay, slightly more advanced now on the absolute value topic. Let's take an absolute value equation where we've got 2x minus 3. Taking the absolute value of the 2x minus 3, setting that equal to 11. Okay, take the basics from the previous two examples. In particular, example number 7. Absolute value here equals something positive. We know this is something we can figure out. So to set this up, I take the expression inside the absolute value. I take that out. I set it equal to 11. Right, we're dropping the absolute value symbols. That's one case. Or the other case, where we basically just write everything the same again, except this 11 now, we switch the sign on. We got to look at the opposite value. You got two equations to solve for. With these two equations we're solving for, since we got the same expressions, we're going to have pretty similar steps to follow, right? We could probably do both of these at once. We're going to add the 3 over. If I do that, I've got 2x equals 14. Over here, I've got 2x equals, that'd be -8. So if I divide by 2 over here, x is going to be 7. Divide by 2 over here, x is going to be -4. So our answers would be x equals 7 or x equals 4. Once again, if I want to use the little set notation, I could put -4 and 7 in like so. I'd say the only other thing I can cover here that has to do with absolute value is something like this situation. That's the thing about this packet. There's just a variety of problems, a lot of situations. I want to make sure I'm giving you an example of each type to play with. Let's take 2 times the absolute value this time of 6x minus 1. Set that equal to 18. If we understand how to break down the absolute value problems we've done here so far, and this is what we're constantly trying to do in algebra once again, we're trying to turn this into something we're already familiar with dealing with. We're used to having problems where we've got absolute value by itself equal to something else, right? So anything else that's attached to this absolute value, whether it's added on, subtracted, in this case multiplied, move that. So since this 2 is multiplied, I'm going to divide the 2 over. Absolute value of 6x minus 1 equals 18 divided by 2. Hey, looky what we got there. Same kind of situation as before, right? So we know what to do at this point. You take the 6x minus 1 out, set it equal to 9. Or for our second case, take the 6x minus 1 out, set it equal to -9. We solve each of these. Going to have similar patterns we're following as we solve each. Going to add 1 to start. So I've got 6x equals, over here that'd be 10. For this other equation, it'd be 6x equals, over here it'd be -8. Divide by 6. All right, if I divide by 6, I've got 10/6. I need to reduce that. Common factor of 2 is shared between the two, so dividing 2 in the numerator denominator, I get 5/3. Over here, if I solve, x is going to equal -8/6. Once again, got to reduce. Common factor of 2, I divide into the 8 and the 6, I get -4/3. So x equals 5/3 or x equals -4/3. If you want to throw those in a set to make it all official-like, you could do that as well. But you got your 2 solutions. All right, I'm going to solve for the capital letter, given all these other variables that are floating around. You need to think about the strategies I've been using on all these other equations we've looked at. This x and this d are attached through multiplication, making this a term. The AC right here technically is a positive term, right? Because the coefficient would be 1 in front. So I need to take that AC, I need to move it over. If this is a positive idea to move it over, I subtract it. Right? How we've been solving all these equations, we're using the opposite operation to move a piece from one side to the other. And that AC is another term, again, because the A and the C are joined by multiplication. So I move that over. If I write this out now, because I got so many variables floating around, it might be a little easier to see. I'm trying to solve for x. So d is attached by multiplication, right? In fact, this is a -1 sitting right here, also attached by multiplication. Let's divide both sides by -1d or just -d. If I do that, negatives cancel, right? D's cancel, and x, that capital letter we're trying to solve for, okay, for the time being, we'll leave it like this, is E minus AC over -d. That would be an acceptable solution. Ideally, though, because there's this negative stuck in the denominator, and having these little random negatives floating around in fractions are never really favorable, you could bump that negative up. make that a -1. If you bump that up, what it does is it changes the signs on these guys. It makes that negative, it makes this positive. So it'd be AC minus E over D. But like I said, don't want to overcomplicate things right now. If you got me to this point, we'd be all good.